All right. Sound? Good. Hello, everyone. Nice to see a good turnout. I'm happy. Okay. Dear guests, both here in the audience and those of you watching us remotely, I'm delighted to welcome you all to the launch event for the Clean Hull Initiative. My name is Runa Skarbø, and I am a senior advisor on maritime and shipping issues in the Bellona Foundation. I'm also the project manager of the Clean Hull Initiative. It is my privilege and great pleasure on behalf of the Bellona Foundation to welcome you here today. We're delighted to have you with us to participate in the launch, so thank you for coming. The Bellona Foundation is an independent non-profit organization that aims to meet and fight the climate challenges by identifying and implementing sustainable environmental solutions. We are solution-oriented, we are constructive, and we are technology optimists. We seek to identify areas of cooperation working together with the industry to find the good solutions, as we believe that you guys are the experts on the matter and that you have the best possibilities to identify the solutions needed. The Clean Hull Initiative is one of these projects. Many of you here in the audience have traveled long distances to be here at Nordshipping. Also, we have viewers on our stream from all over the world, from New Zealand to Australia, Europe, Asia, and the Americas. And this serves as a reminder to us all just how global our work is in shipping and how important it is to collaborate across borders, sectors, and companies to solve global issues. This event is the launch of the Clean Hull Initiative. Although we are launching today, officially, we're not starting on scratch. In September last year, I was attending the Port Pick conference in Siena in Italy. I met many of you there. I was speaking about biofouling as an environmental issue and the need for good solutions. We believe that proactive hull cleaning, the gentle and frequent removal of light fouling, is one of the good solutions to combat the biofouling. In Siena, I claimed that in order to increase the uptake of this approach, there was a need for a standard. I presented our vision of the Clean Hull Initiative to establish an alliance with key stakeholders in both private and public sector to develop this standard. There we go. These were the key stakeholders that we had identified that we wanted to work together with to develop a standard and that we want to have involved. Since that presentation in September, we've had a steady increase in stakeholders approaching us that agreed to the goal that we presented and that wanted to be involved. As of today, we have 18 stakeholders already with logos listed on this slide. But this is just the beginning. What I want to say is that we want to involve those of you watching this, both on the stream and in this room. This event is the invitation to all of you. We hold a strong belief that we can work together to solve at least part of the biofouling issue in the shipping industry. So seeing and experiencing the interest around this initiative, I have very high hopes that this is a topic that engages and that we can do this together. We are honored to have a prominent lineup of speakers with us today, including Angelika Brink from Jotun, Sveinung Oftedal, and also Roger Strevens. Angelika Brink is a senior surface scientist at Jotun and an associate professor too at the Norwegian University of Science and Technology. She has a strong scientific background from both fluid mechanics and surface science. What we know is that there's still a lot we don't know about how biofouling is impacting hull performance. But today she will aim to bridge the gap for us between what we see in the real-life data and also what the scientific theories are on the matter. Sveinung Oftedal is a specialist director in the Norwegian Ministry of Climate and Environment. He's appointed to the Norwegian IMO delegation and is currently leading the working group responsible for the revision of the 2011 biofouling guidelines. And he will share the insights on this with us today. He's also one of the key drivers in the IMO working with climate issues in shipping and is one of the key drivers driving shipping towards more ambitious climate goals. We also have Roger Strevens from Wallenius Wilhelmsen, he is VP of Global Sustainability. His main objective in his work is to advance the sustainability agenda, both internally and also through collaboration with external stakeholders. Today, he will speak to us about the benefits of good biofouling management from a ship owner's perspective, and he will also moderate the panel discussion. I believe the panel discussion will be very interesting. We have experts and players from several different sectors. We will on stage have Roger, of course, and he will be joined by Klaus Winter Graugård from the Maersk McKinney Møller Center for Zero Carbon Shipping, and also Stein Kjølberg from Jotun. And then furthermore, we have 2 more participants joining in via video stream that you will see on the screen behind me. That would be Dr. Marion Tamburi from the University of Maryland Center for Environmental Sciences, and also Luc van Espen from the Port of Antwerp. Lastly, we will round up by having Morten Fon, the CEO and president of Jotun, and myself delivering some closing remarks. Given this lineup of speakers and panelists, I hope you will be enlightened, excited, and inspired. I will now hand over to the word to Bellona's founder and president, Frederic Hauge, to deliver the keynote address. Frederic, for those of you who don't know him, founded Bellona back in 1986, when he was only 17 years old. He is very well known in the Norwegian population for his active work and passion for the environment through the last 36 years. The work of the Bellona Foundation is based on collaboration with policymakers and industry actors, and has led to tangible changes in environmental policy and awareness among political and business leaders, both in Norway and internationally. The Bellona Foundation has grown into an international NGO with established offices in Norway, Belgium, Russia, and Germany. Bellona is the most profiled environmental organization in Norway through the years. It is with good reason that in 2007, Time magazine named him Hero of the Environment. So, before I give the word to Frederic, I want to say once more, on behalf of the Bellona Foundation, welcome. It's wonderful to see that this topic is engaging, and that the Clean Hell Initiative has generated so much interest. I hope that this serves as a start of achieving great things together. Thank you.
Thank you so much, Runa. It's a privilege to work with a lot of engaged experts trying to find the solutions. And in Bellona, we try to pick issues where we make a difference, where we create examples that make precedents. And then, as they say in Latin, navigare necesse est, to sail is a necessity. And if you don't trade, if you don't ship, we have less contact globally, and we all know what's happening then. And shipping is one of the best way to transport goods and get the economy going, but it has challenges. So let's find the solutions together. What we're going to talk about today is, I'm not going to say so much about Bellona, but we use the slogan, from pollution to solution. It was very easy when we started. We break into the companies and digged up their waste. And we got a lot of attention and pointed at the problem. But then the companies come and ask us, what are we going to do? And then we need to find the answers. And that's much more complicated than find the problems. So we have tried to transfer the organization from pointing at the problem to find the solution. And more than ever important, go green by black numbers. And there's a huge shift out there. And I think we used to put it a little bit on the edge. Before Paris Accord, the Paris Agreement, environment was something that was in the communication department. With the Paris Accord, this is now at the top level in the board because it represents financial risk and challenges. And it's a huge, huge shift that has happened the last couple of years on this. And it's a privilege to work with all the industry to find solutions. Runa mentioned that we are quite globally. She mentioned the offices in Russia. It's a little bit complicated situation. So we're all affected by this these days. And we will risk huge challenges with the economic situation in Russia in the future, taking care of all the nuclear waste that we have been working with there for 30 years. So there is challenging times. We are used to take on big tasks. We have done that in Russia. And we're ready to take on new tasks. We have a huge work in Brussels, and we work very closely with the European Commission because that's a good place to get influence. Norway is not a member of the European Union, but Runa is definitely a member of the European Union. And we have also other activities. So this gives us a wide insight, and maybe more than before, it's not a single technical solution that we need, but it's system solutions, that we put things together. And our wide experience enables us to do that. And then one very important thing. We need framework, politically and legally, to do the green shift. In Bologna, we have experienced more than everyone else. Then we go to the politicians, we get one answer. That's taxes. And then they have another answer, and that's taxes. And they have a third answer, you know what that is, that's taxes. So it's the industry that we work together with them that enable us, because it's the industry who knows what
Recording in progress.
Yeah, thank you. It's the industry that knows what kind of framework that does the job that's needed. What we in Bologna knows is that the industry just needs strict and predictable framework that is not changed with every state budget. That we have seen before, then the industry is able to do the change, and that's why we're working with the industry to create solutions. Why is today topics? Biofueling. It goes very slow when you sail around like this. And you bring with you different species that should not be there. This is one of the most important things to do something with if we're going to create the efficiency. And it will be more and more important because, for example, with an electric driveline, this improves or reduces the performance much more on a combustion engine. So when we work with electric ships and all this kind of stuff that we do now, or also with ammonia, the whole performance will just become more and more important. The amount of CO2 emissions globally that will be affected by the right policy on hull performance and the new technologies that we could improve this with is enormous. And we are not going to stop shipping because we need shipping, and then we need to improve this. We have two main topics that we're going to solve here. And there has been a lot of work now on ballast water and been international regulations on ballast water. But what happens with what we bring with us at the hull? And we see the consequences in Norway with the new oysters coming in and destroying all the beaches for the kids. They taste well, but we don't want them. It's just an example why this is so important to find solutions to. We see this on many different topics and quite big ecological consequences. And the global transport is not going to be reduced. We're going to live closer to each other. Shipping will bring different aquatic spices to our ecosystems if we don't solve this. Cost, $100 million yearly. Yeah? It's enormous what the consequences of this is. Maybe the up to 70% of the non-native aquatic species are spread via biofouling today globally. So it's a huge part of the problem. With all the work that we have done on ballast water, it could be quite wasted if we not also solve this problem. And there's a lot of efforts on ballast water. We need to make similar on this topic. Today, the cost of this is, of course, enormous. And with many ships also laid up or waiting in the harbors because it's the race to the port policy, you get a lot of problems when it's standing still, these ships. And this is an increasing problem. We think that in global scale, around 9% of the emissions of the global shipping could be cut by improving this. Yeah? It's a lot. And we work with batteries, we work with ammonia, we work with all kinds of propulsion systems. But this solves whatever of source we end up with to power the ship. This needs to be solved. The cooperation we have with the industry has shown us different solutions. And this is a topic we have been working together with partners like Jotun and others for years together. So we are familiar with this. It's impossible to solve nationally. It's impossible to just solve in the European Union. We need to bring this up on a global scale. But this is, I would not say that is the low-hanging fruits technologically to solve all this. But compared with the other ways of reducing CO2 emissions, this is really where we get a lot of advantages to start. And as I say, it solves the problem for any kind of propulsion systems on the ships. We would like to invite different players to give input to this work. Bellona will work further with our partners to create international regulations and standards for this. And it's extremely important that the industry come with their objections or their suggestions or their advice now, because it's so much more time to redo it if we have gone and given the politicians and the regulators the wrong message. So you now have a chance to influence this by joining this initiative and work together with us, because we want to get it right, and we don't get it right without you. So very happy to have you all here, very proud of the work we're doing. We try to do a difference, and I think we do a difference together. So thank you.
Yes. Can you hear me? Is it working? No. Is it working? Maybe. Should I speak up? Okay, I start. I hope you everybody can hear me. Can hear me? Yes. So what do we know about the impact of biofouling on ship performance? And as Runa said in her introduction, I will make the attempt to scatter some light on into the gap between the reported biofouling impact on ship performance in literature now, which you often probably feel like it's too high, and actually what we observe in real life and what we feel is like reality. So, and hopefully at the end of the presentation, I convinced you that biofouling actually has a much higher impact as we feel in real life. First of all, I actually would like to pick up on a graph which was presented on the UN Climate Change Conference in November last year, and probably a lot of you know. This graph is basically a summary of different published results, but unfortunately not mentioning literature sources. But what was done here, that actually biofouling was expressed over the so-called roughness Reynolds number, or an equivalent sand roughness height presented as the x-axis, as this Ks value you can see. So This Ks value is basically presenting the increase of roughness due to the biofouling and modeling a surface in evenly packed spheres. And this approach is state of the art, so this is very well known, and actually considers that roughness has a different impact for different velocities. So each of these points represent a study from literature, a specific case for a specific velocity. And what is normally done in literature is that you make some experiments on a scale model testing, and you use different equipment like flow cells, towing tank tests, and then upscale this into the full ship using mainly Reynolds average Navier-Stokes equation simulation approach. And we know that there are some over-predictive models and some under-predictive models, and we also know that the experiments are done in a very controlled environment. And I know a lot of you would just look at this graph and say, well, this is really too high, especially if you look at these examples here, the 55% increase with the 1% barnacle fouling. So let us look at some real scale data from us. So here, measured performance data is actually presented as together with estimated fouling coverage rate around a specific cleaning event. And the measured performance data is actually a 30-day moving average around the cleaning date, where also the extent of fouling has been estimated. These are data from 12 vessels only and are based on the deviation from the speed Bauer curve from speed trial test of each vessels. And the negative actually values arise, especially at the beginning of the vessel when it performs, and because often there it performs actually better than its model. And that's actually also interesting because what can we do with this data? I mean, we already know that fouling has an influence here, but we cannot correct it and we cannot consider it. And anyway, we get negative data. But anyway, if you look at this graph, we see some inconsistency. We think like, okay, maybe, yeah, we see not a lot of points accounting for different kind of foulings. But maybe we also feel like we can put a curve in. But let me elaborate a bit on the inconsistency. So a lot of this inconsistency probably comes, and the data spread probably comes to, from the fact that we don't have a way of combining different foulings. That means if you have a vessel which is 10% fouled for thin slime and 10% thick slime and 10% small animal fouling, you will get 3 points for 10% because we don't know how to combine fouling. And then, of course, the transition between different foulings, thin slime, thick slime, it's very subjective. It's dependent on the person reading. However, this is not enough data, so we better remove that curve again. Let's have a closer look on the difference between reality and theory. So what we have in reality is actually, it doesn't work anymore. Yeah, here. We have environmental effects like waves, current, wind, and there are models to remove that effect, but they have a high uncertainty. And then we don't have a good way of combining different fouling kinds. And then we have a much more complicated surface. We have welding seams, we have anodes, we have marking stripes, we have bumps. And we can't just assume that the increase of drag is a simple sum, where the drag increase of each surface feature is just adding up. So we rather have to assume actually that there is an interaction. And then, actually this was emphasized by Schulz already. He was publishing in 2004 that always the largest barnacle on a plate has a dominant impact and the rest of the fouling was not that significant anymore. And then the next point I would like to make is that we basically have an unknown fouling surface coverage. And why I say it's unknown, I mean, there was a person standing there and estimating the fouling. I prepared you some surfaces, and they have different surface coverages, and I just want you to make a guess, like what do you think would be the surface coverage of one of those surfaces? Just in your mind, or somebody can also volunteer, just giving a guess. And I will give you the solution right away. So first one is 15%, that is 1. And for this pact here is 20%. It's not bad meant for me if I say I don't think you were right, because I've done that game with a lot of people, and we have the tendency to overestimate the coverage rate. So, and then if we look at a ship, I mean, this is varying level of slimes. So we increase the complexity suddenly. And here hard fouling, this is basically, I would say it's impossible for a human being to estimate the coverage rate, but this is what we do. We look at a ship and we think about the coverage rate, and then we look at the performance data. And then we get a feeling. So I would just like to continue on the exercise here and the comparison between reality and theory. So what we have in theory is a controlled environment. Fouling is actually converted into roughness based on different methods, which is a big advantage to real life, where we just have the different foulings and we don't know how to combine it. And we have often single fouling events and no interaction of surface features. And very simple geometries, plates and not a ship hull. And of course, what I emphasized before, we have a known coverage rate. And now, going back to the 2 graphs I showed you, now with the same axis. If we compare them now, of course, we cannot compare them directly, because one is showing the extent of fouling and one is showing actually the biofouling roughness. But if you look at the light green dots from the thin slime of the real scale data, we see an actually impact of around 5 to 25% on the power performance. And this is very in line actually with the literature results, because here you also see an impact up to 20-25%. And just to mention that, the increase in greenhouse gas emission can be one-to-one transfer to the power increase. And this is actually where we want to work for the pro hull cleaning. We want to remove the light slime, and we don't want the fouling to grow. But anyway, that's a kind of a big influence, 20%. So if we now have all this in mind, the overestimating of coverage rate, which actually would shift the point, we shift the point cloud to the right, and actually we have underestimate our impact of fouling by doing that. So, and the difficulties in categorizing fouling, we actually maybe think the difference is not that big anymore from literature to real life data. So, just a short summary. I want to emphasize that the impact of fouling might be significantly higher on the power deviation of a ship as we assume by today. And we think we know from real life observations. And we should actually probably consider the clean theoretical results, which I presented here from the summary from the UN Climate Change Conference as a reference if we start evaluating the impact of fouling. And this is to summarize because of the high uncertainty in coverage rate estimation, the high uncertainty of data correction, and the impossibility of combining fouling events, and the influence also of the fouling distribution on the hull. So for the future, besides the fact that we should gain much more data, collect much more data, we should also focus on the correction of the environmental effects, the coverage estimation not done by humans anymore, and the influence of the ship area, and of course the interaction of different surface effects. Thank you very much.
Then I just take the stage. Is that okay? Fine. I'm happy to be here. My name is Sveinung Oftedal. I'm from the Norwegian Ministry of Climate and Environment. And I'm going to present what we are doing at the IMO in order to revise the guidelines on biofouling. Now, why do I show this picture? Sea vomit. The last year, this has been in the Norwegian media as the latest famous invasive species in Norwegian waters. It's not supposed to be here. When it's introduced, it's very difficult to get rid of it. That's only one of several. In the European waters after the Second World War, it is estimated that approximately 1,050 invasive species have come into the marine environment in European waters. And 50% of those species is brought by ships. Now, of those brought by ships, 50% is by ballast water, and the other remaining part is the biofouling. Now, Mr. Hauge said that this was a lower-hanging fruit. It's not only a lower-hanging fruit, it is one of the major ecological problems in the oceans. So we need to fix this. That's clear. But it is also a low-hanging fruit. That's clear. I'm also involved on greenhouse gas emissions work at the IMO, and meaning this is what also we need to do in order to resolve that problem. So, biofouling, what are we doing? First, I think you should go prior to 2006, because in 2006 we agreed at the IMO that we need to have guidelines on biofouling. Prior to that, in 2004, we adopted the Ballast Water Management Convention. In the late 90s, we had also guidelines, only guidelines on ballast water management. And what was required in those guidelines, not required, recommended, was to have ballast water exchange as the solution. Now, we decided then to go into mandatory requirements. And when we started that work on ballast water to go into mandatory requirements, we also went into discussions on standards, what to do. Ballast water exchange is not fixing the problem. So we decided we need to have a treatment system installed on all ships. Now, that we decided, and that will be installed on all ships in international operation by 17th of January 2024. Yes, many years has gone, but we have made it. I think globally, this is the most firm actions taken in order to preserve biodiversity. We need to do the same on biofouling. We started with guidelines. We adopted those guidelines in 2011. Now, those were important, of course. Industry is supposed to apply them, and member states are supposed to apply them. We know that the guidance in those guidelines is more of general nature, and we know that the uptake is not to the extent we should wish. So we decided we need to revise those guidelines. We did that in 2018, and I'm coordinating that work at the IMO. In addition, in 2019, we also have a project to assist developing countries. Also, we did that when we dealt with the ballast water, to assist developing countries in order to improve their knowledge and focus on biofouling, in order to make them ready to take action on biofouling. Also, from the Norwegian side, we have supported now the IMO also to have technology focus on what to do on biofouling in developing countries. Now, where are we at the moment? We are actually in the middle of our work. Actually, we have done some work this week because the Marine Environment Protection Committee has instructed a subcommittee. I know this is complicated. A subcommittee to do the work. So when the subcommittee do the work, it recommends to the committee, here's the result, and the committee says, fine. We're gonna complete that work in 2023, meaning that what will we focus on? Of course, both the uptake, those guidelines need to be applied. We know that there are some countries having mandatory requirements, but member states need to apply them, and industry. And also the effectiveness, not only general guidance, to be more specific on what to do, how to do it, and when to do it. In addition, of course, we need to have the more clear identification on the various stakeholders, with various responsibilities. And then let's now introduce you to what it contains. It contains the full life cycle of a ship's brought into operation and during operation, meaning when a ship is designed and also when you have the anti-fouling systems applied, we need to have in our mind that we need to prevent fouling. Look into, is there any potential niche areas? Is there any kind of measures we can take prior to the ship is put into operation? And when the ship is not into operation, it is about preventing the fouling in the full cycle of the ship. That is more or less what it contains. And here is the list of content of these guidelines. Now, what is the main aspects? Well, it is an aspect that you need to inspect. We have decided we need to have a risk-based inspection, meaning that if you assess that there's a high risk for fouling, you need to inspect more often. And then we have a default value, meaning that you should not exceed a certain time in order to inspect whether or not you have any fouling and whether or not you should take any action. That is one element. And then when you take action, we are addressing proactive action, meaning a proactive cleaning, and reactive cleaning. And when we are defining those actions, of course, the quality of the cleaning will be very important, and also the rate of collection of the foul material will be very important. And also, of course, to ensure that the quality of the anti-fouling system is maintained. Now, if you remember my explanation of the Ballast Water Management Convention, when we developed that convention, we didn't have treatment technology on board. We didn't have it. So the IMO said, this is the standard, and the ballast water treatment standard at the IMO is close to drinking water, more or less clean everything. And then that provided the industry to develop systems. I'm not saying that all of them is perfect, but they need to pass a test. So that standard triggered innovation, triggered then testing and approval. And hopefully, I see there are people from shipping industry here. Hopefully those ballast water management treating systems is functioning and is operating okay. Now, on biofouling, we will go into the same route. When we have revised those guidelines, I guess there will be pressure to have it as mandatory requirements. And when we develop mandatory requirements, I guess we will go even more into the depth of these standards to prevent the spreading of invasive species, meaning also the rate of cleaning and the rate of collection. Now, in addition, ships need to have a ballast water management plan and need to have a recording of whatever you do. And when you enter into a mandatory regime, there will be then standardization, so there is verification and enforcement actions by authority. That is when you have mandatory requirements at the IMO. When you have voluntary guidelines, that will not take place. It's then up to industry in order to document that you have a system which is in accordance with the recommendations in the guidelines. Now, here you can see a system in operation, cleaning the hull, and I think I'm coming to the end because I have a timeline limit. I want to address two elements. When it comes to fouling, your picture, Frederic, was quite a fouled ship hull, a leisure craft. Not yours, not yours. Okay. Now, there are various degrees of fouling, and this is from bacteria until the biggest things that can grow on a hull. What you see here is what we can see with our eyes and we can see in the media, and those are the famous species. However, all of those are important in order to preserve the ecology of the oceans and also the economy of the oceans. What are we doing? Fish farming. What is the value of fish farming? What if we have some algae or other smaller species introduced? What threat is that posing? In the early 2000s, we remember the Chatonella algae introduced in our waters, having to remove those fish farming facilities. So it is a threat to the ecology and the economy. Now, when it comes to these guidelines, we have then defined what to do with microfouling, what we can do with microfouling, and what we can do with macrofouling. So that is a very important issue. And 1 minute left. It's about me to say then, this is the last thing I think we'll say. that recommendations for how to prevent spreading will be a key issue in the further work at the IMO. And IMO will, and I guess all of you are shipping people, develop standards for shipping. So that was the last slide for me, and I say thank you for the attention and good luck with your work.
Good afternoon, ladies and gentlemen. My name is Roger Strevens. I'm from Wallenius Wilhelmsen. It's a great honor to be part of this launch event. We're very proud to be part, we're very excited about the potential that this holds. I'd like to commend Bologna for their initiative with CHI, and I'd like to acknowledge the great leadership we've had with Runa already with this. I feel that we're in very good hands. I'd like to talk about this topic on two perspectives. Why the whole area of hull cleaning is of such interest to us as a company, and why this initiative is so important to us to be part of, and what we hope to achieve from it. So, Wallenius Wilhelmsen is a deep sea shipping company, and we are operating 130 of the kinds of vessels you see here in the image in a global network. We're calling ports right across the world, in all waters, well, except at the poles. And those 130 vessels, they require a vast amount of energy. And that energy, represented by about 1.2 million tons of fuel per year. That's what we're consuming. We'd rather it be zero. That would be, our preference would be to sail downhill. But so far, we haven't found a way to do it. That 1.2 million tons creates around 3.8 million tons of CO2. Again, this is our challenge. We want that to get to zero. And that challenge, anything that we can do to reduce that number, that's a huge win for us. So just take a scenario. If we, by focusing on hull fouling, we could reduce consumption by 1%. And think of what you've seen in the hulls at North Shipping. There are so many initiatives that are offering far more than 1%. But let's stay with this as a conservative figure. That 1% represents 12,000 tons of fuel per year, just for our fleet. And therefore, 40,000 tons, plus or minus, of CO2. It's a vast number, just from one fleet. But there's another way to look at this too. Currently, fuel prices hovering somewhere around $875 per ton. So let's put that, for the people who don't understand the environmental language, let's put it in the economic language. It's 10.5 million tons, $1 million per year, rather, I should say. That's an enormous number coming straight off the bottom line. And so talk about the motivation. This is both making something that makes environmental and economic sense. That's the holy grail of environmental solutions. And so, Frederic, you mentioned in your presentation, there's an opportunity or there's a waste here of hundreds of millions of dollars. I think you're lowballing that number. I think it's much bigger than that, because it's not just 1%, folks. That number is really a lot greater. And we've been through reactive hull cleaning. You take action when you know you've got a significant issue developing. Now we're making the transition towards proactive hull cleaning. There's a really good parallel there between maintenance of a vessel. And for many years, the focus was shifting towards preventative maintenance. And now we're into the realm of predictive maintenance, understanding, anticipating what's necessary to do. That's the most efficient outcome. So this is, I hope I make a clear case, these numbers speak for themselves on why it's such an interesting issue. And before I move on to the second topic, is that it's not just a win in terms of CO2. It's a win in terms of all emissions, whether it's SOx or NOx or particulate. And it's not just that either. This is a win in terms of invasive species transfer mitigation. So I think the case here is really pretty strong. So let me then move to this. Why is this initiative so important, and what helps? Well, I think the case on the wisdom of taking a proactive approach, I think that hopefully I've established that by now. But the need for this initiative is that I think with this more than any other of the environmental issues we have, there's a patchwork of different initiatives from ports across the world. And I understand the need to take action when there isn't a clear direction at an international level. But this is really far from optimal in terms of the interest of dealing with the issue and from a ship operator perspective, because with this patchwork, it adds complexity, operational complexity. It adds risk for us. And again, to echo your point, Frederic, if there's one thing we like, it's predictability, having a predictable environment. So I think that's why this policy focus is so important to us. And in developing a good policy, I think there are a few major elements that we can identify. Our preference is for a goal-based outcomes. That keeps the, rather than specifying technologies that have to be or that should be used, tell us what kind of standard or outcome we want to achieve. That keeps the emphasis on innovation, which is good. Let's try and achieve then as much of the positive changes we want for as little cost as possible. That's good regulation. And avoid being brought into the land of unintended consequences where something else that worked very fine before is now disrupted. I think another key element here is the effective enforcement. Whatever measures are introduced should be possible to enforce so that we preserve the level playing field. And that's a point that becomes ever more important as the cost of compliance increases. Then, and I think this won't be any surprise to those who are familiar with the voice of international shipping, is that we are a global industry. And our strong preference is for global regulation for so many different reasons. We also think that that good policy should have an even-handed approach to all parts of the industry. Those who contribute most to the problem should carry most of the responsibility to addressing it. And then finally, that we want to protect the rights of those who act early and in good faith. And this is a regular sort of recognizing initiative where goalposts are moved. And those who took the initiative early ended up having to pay twice as dearly for it. So those are some general principles, I think, that help us point us towards what a really good outcome would look like. And so I think it may be messaging which is maybe for some a little bit unfamiliar from the shipping industry. We have a reputation. I don't think it's deserved across the board for being very conservative. But here, what we are looking for is the same, not different. The same across the world. That's really what we do want in this case. So with that, I'd like to call to the stage the panelists. We have a pair of panelists who are joining us in 3 dimensions, and that is Stein Scholberg. So Stein is the Global Category Director for Hull Performance with Jotun. And we're being joined by Klaus Winter Grogard, Head of Onboard Vessel Solutions for the Maersk McKinney Møller Center for Zero Carbon Shipping. Then just in 2 dimensions, but no less significantly, we're joined through a live satellite link-up by Luc van Espen, who's the Technical Manager for the Environment at the Port of Antwerp. And then finally by Dr. Mario Tamburi, who's the Director at the ACT Merck Center and Professor at the University of Maryland. So very, very glad to have you all part of this panel discussion. There's a very broad depth of experience and knowledge, and hopefully I'll be able to draw this out. if I could begin with you, Klaus, can you paint a picture for us of how this initiative fits with the broader work of decarbonisation that the centre is working on?
Yes, I think this is on. Thank you very much, Roger, for this possibility to address you at the panel today. Yes, definitely. I think the initiative and some of the numbers that we already seen here today obviously makes a lot of sense. When we at the center look at the transition for shipping as a whole, we're looking at a problem where we today are facing an emission of about 1.3 gigaton of CO2 from a well-to-wake perspective. And this is the major problem about that. With the increase in expected trade growth in the next 30 years, with the regulation and the technologies that we already have in place, if we were not doing anything extra from here, we would actually see an increasing amount of emissions in the next 30 years. And the ambition obviously is for the sector that we work toward a net zero in 2050. So the gap is tremendous. It's actually from an increase from what we call the path we're on, maybe increasing to about 1.5 or 1.6 gigaton of CO2 from a well-to-wake perspective down to a zero. That's the big gap that we would like to address. In this, there are various levers or critical levers, as we like to call it, in our strategy for the sector. One of these critical levers is energy efficiency measures. This is an area where all the known technologies, the best practices of engineering that is already out there, the best practices of fleet operation, digital solutions that we already know are proven and available, can make a tremendous difference for the industry and maybe hold potential of taking out on the world fleet power demand in the magnitude of, say, 15% if you are applying all the best practices of engineering, not just for hull founding and best practices of performance management, but also other solutions for energy efficiency. If we look at the issue on the power that you are referring to, if we look at a fleet that is now consuming about 300 million tons of fuel oil on an annual basis, and take that into perspective, about if we could save 10% of that, that would be about 30 million tons of fuel oil. And if we then take that into a context of the discussion about new alternative fuels, like an example of ammonia, that would then convert into almost 70 million tons of ammonia. If you were to produce 70 million tons of ammonia, that would require about 175 installed gigawatt power of renewable energy sources, being wind turbines, being solar cells, whatever you need to do the green electrons, to do your electrolysis processes and do power to X fuel and synthetic fuels. In Denmark at the moment, you have quite a big wind farm installed across the country, onshore, offshore. That is now accumulating to 6.5 gigawatt installed power totally. We have spent 20 years of getting to that number, and of course it's accelerating. But as I just said, to produce 70 million tons of ammonia, green ammonia, that requires 175 gigaton of installed power versus now 6.5 gigaton installed in Denmark. So that's the problem which we're looking at. So if we could take out what Frederic was alluding to, 8-10% of the equation by proper biofuel and hull performance management, we could maybe take out something like 1 exajoule of fuel on the propeller, the required power on the propeller. Remind you that to produce 1 exajoule of power on the world fleet propellers, it goes through an energy loss of 50% on the diesel engine. So that requires 2 exajoules of energy power before the engine. If we could remove 2 exajoule worth of fuel, of existing fuel oils or new alternative, very scarce produced low carbon or zero carbon energy carriers, this would have a significant impact of actually getting there and making the transition a realistic project. And it will make a lot of sense for the individual operators, taking out costs, as Roger was just giving us the example of, and saving emissions. And this is solutions that we could do today. Solutions are there. We need to illustrate, we need to educate the larger industry, because those of you, you've been doing this for 10 years or more, you are very, very educated in this. You know what it can do for your fleets, but there is a huge need to educate and implement the best practice. And that's why we salute the initiative of the Bologna Foundation to do the Clean Hull initiative.
Thank you, Klaus. You really laid forth a very clear argument for the scale of the challenge that we face by not doing, by not taking all of the possibility, the opportunity, and that's really the word I want to focus on, from better optimal hull fouling management. One of the terms you mentioned was operational efficiency. And that's a theme which has certainly caught the attention of the regulators. And soon we're going to have some regulation called the CII from the IMO. This is the Carbon Intensity Index, which will take effect. Stein, could I ask you to share your thoughts on how this initiative will play into that regulation?
I'll be happy to, Roger. Does this work? Thank you. The issue of what we talk about here is really dealing with a problem before it becomes a problem. And as you mentioned, if you resort to the normal means, which is reactive cleaning, that means you deal with the problem after it happens. And what happens normally then is it takes 6 months from you see the problem until you deal with it. That really creates an inefficiency, a competitive disadvantage for the shipping industry. By being able to handle this at a much earlier stage, before it becomes an issue, to deal with microfouling before microfouling affects the ship. If you have a good anti-fouling system, well designed for a predictable trade, it normally works. But we know in the coating industry, life isn't that easy. We also know that for our shipping customers, the moment you start deviating from your ideal performance, you will end up in problems. The new CII regulations that come into place means that you don't only have one specific target, it's a moving target, and it is getting stricter and stricter year by year. And whatever you do today will have an impact in 5 years. If you're not able to perform or protect the ship, protect the hull in a way that means you can follow this trajectory, then you could end up, if you today are happy with a C rating in CII, and you think, well, that's fine. In 5 years' time, that might be an E. And that might you might not be able to trade anymore. You're taken out. You have to deal with a lot of issues that you didn't really plan for. So thinking today, what happens in 5 years is essential. So for us, EXI, of course, it makes an impact, but CII is really the issue moving forward.
Thank you, Stein. And I think that your point about how paying attention to this issue can be the difference between a C and a D, a C and an E or rating. I think if that doesn't sound real at the moment or sound urgent, it soon will. Yes, it will. I'd like to turn now across the ocean to Dr. Mario Tamburi, who's been kindly joined us at an unholy hour of the morning. And Mario, could you share your thoughts on what's the state of technical readiness to deal with the opportunity that we have with proactive hull cleaning?
Yeah, thank you, and good morning, everyone. It was really interesting to hear the discussion on the parallels between what happened in ballast water and invasive species and now what's happening in biofouling, because I think there's a lot of lessons to be learned there. I think we're in the early stages of these new innovations. I think there are many of them out there that are being developed. They show a lot of promise, but the real goal, the real success of all this is dependent on safe and effective, proven innovations, technologies that can address, in this case, proactive cleaning of ships. Then the standards for how they're operated and their best practices and so on can be implemented in an effective way. And then regulations can also be effective and successful. So while I think there are a lot of good ideas, a lot of good innovations out there, some are more mature than others. I think we also have to be patient, let them mature, let them be proven, let them fix initial bugs that they find or challenges that they find they didn't anticipate. But I think we're on the right track, and I think there's a great chance of success.
Thank you, Mario. Could I follow up with a question, though? You talked about the need for safe solutions. And can you expand on what do you mean? Do you mean safe in terms of environmental impact or in the physical fulfillment of these services?
Yeah, I mean, I think it's all encompassing. I'm happy to explain in more detail. So first, these technologies need to be effective. They need to actually do what they're designed to do, and that is to minimize fouling and to increase vessel efficiencies and to minimize risk of invasion. So that's part of it. But they have to do that in a safe way. And safe can be in terms of not themselves exacerbating environmental problems, whether it's accidental release of invasive species, whether it's enhancing the release of biocidal compounds and coatings, but also safe for the vessel itself, for the coatings themselves. You don't want to have impacts on anti-fouling coatings from the cleaning system that reduces their lifespan, for example. And then ultimately safe for operators as well. If these are diver-driven sort of systems, you want to make sure that that's a safe operation. So you have to think about the process holistically and make sure that it's fundamentally meeting its goals of increasing or minimizing fouling to increase operational efficiencies, but also doing it in a safe way.
Thank you, Mario. Luke, could I turn to you and ask for you, what's your view on the safety aspect from the port operator perspective? And also perhaps you could share your thoughts on why is standardization of an approach, of proactive approach to cleaning, why does that matter from a port's perspective?
Yes, about the safety aspect, let's say that first of all is the biological safety, because as a port authority, we prefer ships arriving with a clean hull in order to prevent the introduction of alien invasive species. On the other side, safety from the operational point of view is something evident, I guess. We always look after when diving operations are busy in our port that no other ships are sailing close by when divers are busy. But I understand from the new technologies as they are developing now, both from proactive cleaning as on reactive cleaning, that the companies use more and more ROVs, robotic vehicles, without any diver into the water. So the safety aspect is quite ensured from that way. And then I was thinking, what was your second?
What's the question? And thank you for that. The question was: is a standardized approach to proactive hull cleaning, is that important for ports also?
Yes, of course. Yes, of course. This is important because it's not feasible to make an approach that is different from every port. As such, not for the shipping industry, not for the ports themselves. So we are. Let's say favorites of having a standard approach. So for example, about reactive cleaning, we have been developing some standardized approach in the procedures to admit diving companies to perform such of operations in our ports. So we have been developing a standard all over the Flanders region, which is the northern part of Belgium. But we would like to have it standardized, if possible, all over the world, so that diving companies, port authorities, governments, and the shipping industry know what to expect, and expect the same thing all over the world.
Thank you, Luke. Stein, can I come back to you? And I know that you've had some experience with proactive hull cleaning systems, and what can you share about it, and what kind of in the practical approach to proactive hull cleaning?
I think the main thing here, and it goes a little bit back to what Luke is saying, is that when you deal with proactive hull cleaning, it's almost like brushing your teeth. You do that not when you have cavities on the teeth, you do that on a regular basis. And in order to do so, you have to take away whatever is present. And you do that at such an early stage that what you take off the ship is only the microfouling. You cannot touch the anti-fouling, you cannot touch the leach layer, because that will then upset the ecosystem in that local port. And if you do so, then the ports will not allow us to operate in such a way. So this is key. And it's what we have done so far is to test this in a quite stringent way and approach the ports, and this is the way to do so. So whoever operates with proactive cleaning, whatever means and measures and methods and machines or whatever, that is key to the success here.
Thank you. And as a ship owner operator, we couldn't agree more with your comments about looking after the hull coating, because this is not paint. This is a critical ship system, and not one that's inexpensive either. So, Klaus, that wasn't a protest. Maybe a little. Klaus, so the Maersk Center is really built, I think, with the idea of collaboration as being a foundational element. What can you, because you've been working now for 1.5 years or 2 years, what advice or insights could you offer the CHI as it starts out on its journey, and I think for which collaboration is going to be a really critical component?
Yeah, no, that's for sure. The way that we are building the Zero Carbon Shipping Center is based on a mutual trust foundation, where we are bringing in strategic partners that all bring in secondees. That's actually the main obligation for the strategic partners, is that they bring competences into the center, typically contributing with about 3 FTEs per strategic partner. And the platform is now offering an opportunity for like-minded companies to work on these various difficult problems on the way to net zero. Anything related to energy efficiency, which is a full program in the center now, where we have a working group that is bringing along all the partners. But also inviting external parties or stakeholders to that working group and that program to contribute with deep dive technology know-how or operational insights to hack these problems together. And I think just from the 1.5 years we've been operating now we start to see that the mutual trust is really gaining momentum, with the secondees being in Copenhagen, collaborating across the value chain, anything from ship owners, technology providers, fuel producers, and so forth, that they actually sit in the same room. They work on problems every day, and the IP rights is already described on our strategic partnership agreements. So that is kind of like getting more and more in the background. Now they're focusing on actually working on the problems together. And we see the strength and the motivation of these really major corporations, that they educate themselves in the unknown territory of what the transition and the problems that needs to be solved can do, and see the value of collaborating, bringing their specialist subject matter experts into a collaborative area, and actually meeting like-minded to work on this. So this could be the area of good practices of hull performance, that you would bring together a group of people that would sit together and actually bring into the light the best practices and solutions. So this has a huge potential, and we encourage also to work with Bellona and this organization and bring that into our work and spread, you can say, the network of collaboration.
Super. I like the point that you made about the importance of educating ourselves about this topic. And with that thought in mind, maybe, Luke, I could go back to you and ask you to comment on where that tipping point is, where proactive cleaning becomes reactive cleaning. How do you actually differentiate what these two approaches are?
That's something different to judge. The proactive cleaning should be, or the fouling should be as small as possible. How do I say it? more the fouling is extending, more you are reaching to reactive cleaning, and some of our concerns is that if we handle the principle of a ship clean before you leave, that it will arrive clean in our ports, and having not too much of fouling on the hull, because the typical way of working in proactive cleaning is that this happens with a robot, of course, but there's also no capture of the fouling and paint rests, let's say. So therefore, the degree of fouling should not be too extended. So I've been reading, for example, in a document from Professor Tamburi, that the maximum degree of fouling should be some 20, how do you call it, degrees or percentage of fouling rate, American fouling rates. I think that will be the utmost maximum you can accept before you go over to reactive cleaning.
Thank you, Luke.
Yeah.
Stein, from the experience that you've had, and I think this is Stein and Mario question rather, how do you actually measure the level of fouling, and whether a proactive or a reactive approach is more appropriate?
Mario, would you like to take that from first?
Yeah, I can give it a go. It's a really important point, and I think it's one of the most important issues that needs to be addressed at a variety of levels, including what's happening with the revision of the IMO guidelines around biofouling. There's different ways of doing it. You can do it sort of taxonomically when they become higher organisms like invertebrates or macroalgae. You could say that that's in one class. People do size or visible to the human eye becomes macrofouling. The one thing that's really important, though, to remember in all of this is that unlike ballast water, we have water contained in a tank that's discharged through a pipe. Biofouling is different. Biofouling is always open to the environment. And so ships now coming in, independent of in water cleaning of any sort, are releasing organisms. It happens. They spawn, they break off. There's interactions with tugs or fenders that cause things to slough off. So it's an open system. How we decide when we move from proactive to reactive depends on what your end goal is. If it's an operational one or if it's a biosecurity one, but it hasn't been clearly defined yet. And I think that's maybe something this initiative can help think through.
Excellent.
Just add a comment. It's back to what Angelika also said. What you see visually is not always what is the actual state. But if you follow then the normal guidelines, fouling rate 10 or 20, that stays within the range of proactive cleaning. Anything above that, then move into macrofouling, and that's reactive cleaning. How you actually measure that? Yeah, we get back to that in this work.
So, thank you. We have one final question, and that's Stein, to shipping companies who may be considering engaging with proactive cleaning. Where do they begin, and what level of operational disruption should they anticipate from this?
Well, first of all, I think that you should reach out and join in on the Clean Hull initiative, because this is where it happens. If you want to have an influence and guide this work the way you think it's the best for you, then join this initiative. It doesn't cost you anything apart from some work. And the more work you put in, the better outcome you come. So I think that's the best starting point. And you can seek then help from coating suppliers and producers of different instruments as well. Thank you.
Thank you. So with that, I'd like to thank the panel very much for their excellent insights and for being so generous with sharing them. And I'll pass the word back to Runa now for closing remarks. Thank you very much. Thank you.
Thank you. I'm joined on stage also by Morten Fon, that is going to say just a couple of words before I'm going to close. So, Morten, stage is yours.
Yes, first of all, I would like to thank Bellona, Runa and Frederic for the initiative as such, but also for gathering us here today. Thank you to speakers. I think you shed light on a very, very important topic. So thank you very much for that. And to the audience, thank you for coming. I hope you had some learning in this. From my point of view, the challenge is clear. We have to make sure that we fight the spread of invasive species. So that's one part of it. The other one is to fight biofouling. I think we all have understood this after this hour. And of course, to do that, what we have to do is to create an efficient hull. So all this is linked together. And I think one thing that we haven't touched very much upon, Frederic, you touched upon it very briefly in the beginning, is that this will be important regardless of fuel in the future. Actually, with the new types of fuel coming, it will probably be even more important than before. So we cannot hide behind new fuels, more environmental fuels. We have to fix the biofouling issue. And we can do that as an industry. And the good thing about that, again, is that here environment and economy goes hand in hand. Because if we make the hull more efficient, we will use less fuel and we will make more money. So all of this, I think, goes very well hand in hand. So we have a shared goal here, and that is to come up with new standards, new regulatory systems. And how can we do that? We have to do it by collaboration. We heard from the government, we have heard from IMO, and the industry has to be part of that. So in totality, we can do this, but none of us can do it alone. We have to do it together in collaboration. And wasn't that the theme of this conference? So I think let's put in work. Those of you who hasn't joined the initiative, join the initiative. We can do this together. And thank you again to Bellona for the initiative.
Thank you for that, Morten. All right. Thank you for those words, Morten. So this has been very enlightening, at least for me. Now with this, we've reached the end of the event. Now I want to first of all say a big thank you to all our speakers and panelists. Thank you for being here and for sharing your insights. Before we close, I'd like to just spend a brief moment to recap kind of the key takeaways from today. I know that Angelika was speaking about how biofouling is impacting hull performance, what we know and what we don't know, and it's still very clear that we might not fully understand all the aspects that play in. We even have some maybe indications that we are underestimating in some ways and overestimating in other ways. So it's clear that we need to work further on this. However, one thing that we all agreed on, from the scientists to the ship owners, is that it's impacting the hull performance negatively. It's not a very radical statement. This was also further underlined by Roger's presentation. He shared some insights from why this is an important topic also from the ship owners or operators' perspective, and how good biofouling management is a benefit. So the key word is good biofouling management. So it kind of brings us also to Sveinung's presentation, where he was talking about the issue of invasive species and the safety and how the IMO is working on this. And of course, a key takeaway was that, I mean, not only should it be good from the shipping side, but it needs to be safe. We need to prevent also the spread of invasive species. Again, that was also a topic for the panel discussion. It will be a key issue when IMO goes forwards, and it's also a topic that I think we will take into this work. So what is safe proactive hull cleaning practices? It has a lot of aspects. And we don't have all the answers yet, but this is why we want to invite you in. Like Stein was saying in his remarks also earlier, we want this to be a collaboration. We need to come together. Collaboration, like Morten said, is the topic of the conference. And I think it's really kind of dawning on all of us in the shipping industry that we need to do all of this together. We have a huge transition on so many fronts that we're going through. This is just one tiny part of it, but we also need to do this together. Speaking on behalf of Bellona, coming back to that, our key concern is the environment. So we hope that this collaboration, this initiative, will be the key to find this balance between safe and good biofouling management practices, in specifically focusing on proactive hull cleaning. And it doesn't necessarily, I hope, have to be a contrast between them. Hopefully we can find the synergies. So, as stated in the beginning, this event is the invitation to all of you here in the room, watching on the stream to join the initiative. We have a lot of work to do. If you're interested in joining, or at least triggered, interested, please reach out to me. I'm the girl you need to talk to. For those of you in the room, my business cards are over on the table. Come talk to me. My email address is on the flyers. Those of you watching online, yeah, reach out by email, LinkedIn. I've been spamming on LinkedIn, so I think you know how to find me by now. But again, it's been a pleasure being here with you today. Thanks again to the speakers, panelists. Thanks for coming. Thanks for watching, everyone online. And with this, I wish you all a good day. Thank you.